Electromagnetic interference, or EMI, is the invisible enemy of high-speed digital circuits. If left unchecked, it can degrade signal integrity, cause regulatory compliance failures, and even lead to product malfunctions. But how do we suppress EMI effectively in high-speed PCB designs? Let's dive into the key techniques used by engineers to keep signals clean and systems reliable. At high frequencies PCB, traces behave more like antennas than simple conductors. EMI is generated due to rapid switching, improper grounding, and unintentional coupling between traces. There are two primary forms of EMI conducted, which travels through power and signal lines, and radiated, which spreads through electromagnetic waves. Both need to be carefully managed. A well-designed PCB stack-up is the foundation of EMI control. A well-designed PCB stack-up is the foundation of EMI control. Using a continuous ground plane helps reduce impedance, prevents ground loops, and provides a return path for high-frequency signals. A 4-layer board with dedicated power and ground layers significantly outperforms a 2-layer board in EMI control. Avoid sharp bends and right angles in high-speed traces. They can act as unintended antennas. Maintain controlled impedance and use differential pair routing for signals like USB, HDMI, and PCIe. Also, spacing high-speed signals away from noisy power traces prevents unwanted coupling. For sensitive circuits, using metal enclosures or shielding cans can prevent radiated EMI. Grounded shields act as Faraday cages containing noise inside and blocking external interference. Ferrite beads act as frequency-dependent resistors, absorbing high-frequency noise while allowing DC and low-frequency signal to pass. Decoupling capacitors placed close to IC power pins stabilize voltage rails and reduce EMI from power fluctuations. Using differential signaling reduces common mode noise. Paired traces carrying equal and opposite signals cancel out interference. Impedance matching ensures minimal reflections, which are a major cause of EMI in high-speed systems. Even the best designs need verification. EMI compliance testing using spectrum analyzers and near-field probes can identify problem areas. Pre-compliance testing before regulatory certification can save costly redesigns later. To build robust high-speed PCBs, always follow EMI suppression best practices. Use solid ground planes, route traces carefully, apply proper shielding and filtering, and validate your design with testing. By taking these steps, you'll create more reliable, interference-free electronic systems. Want to learn more about high-speed PCB design? Subscribe for more insights